explain that here on screen. It's probably easier than if I try to give a concise explanation in the chat here. However, it looks like it is not possible to actually put something on screen which I can interact with if I also have those annotations here, which is surprising. Okay. Let me see how we can do this. Okay, this works. So you should be able to see and even to read my terminal session here. Well, and just to start into that, we have well, the show schedule command. I have the command, the tab completion here, and you see this is not exactly the identical scheduling that we see in the course setup, right? It's what I have in my lab and office Bacula instance. However, we will be able to identify the interesting things here. So let me pick a schedule that has the same peculiarities as the one from the exercise. That would be for me the ones that I have with the LC in there, which is my abbreviation for low churn, meaning low change rate. So I don't need full backups that often, I decided. So if I do that, we have something that I can get a bit more readable, yeah, like that. So the output is the same basic structure, you know, right? The schedule itself, the global parts for the schedule, it's got a name, it is enabled. And then we have, and this is the example we will be using for the overview of what we have here. For the full backups, we run those, and this is how to read this at 23 hours, 5 minutes. So those are the field names for the hour and the minutes for the times. This is, I guess, quite straightforward to understand internally. And this is where it already gets interesting if we are talking to people used to 12-hour time formats. Internally, Bacula stores times in 24-hour time format. So this is 23:05, 8:05 in the evening, 11:05 in the evening. Hours and minutes. That's easy, I think. We have then the month in the day. Those are the what is it, the plain numbers in the schedule. This means on the 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th day of each month. And of course, you notice one thing, internally we start counting with 0, even though we clearly specify that the user changeable settings, well, if you will, the front end side of things is, of course, counting with 1. The reason for that will hopefully become apparent in a few minutes. Then we have the number of the months, just the plain numbers. And well, again, we start counting at 0. So this means month January and month July. So I suspect you're seeing what that leads up to. This is leading to a schedule that triggers inside the first few days of January and July, so twice a year. In other words, in opposition to what we have in the exercise, where we said do a backup every 2nd month, here I have a situation where I said I need a backup every 6 months, twice per year only. Well, then we have the weekday that we are counting, and the weekday, as we have it here, is the number 6, which is Saturday. for me in this case. We start counting the weekdays with a 0, and well, internally. Externally, we don't have numbers for them. We have to specify Monday, Tuesday, whatever. And Sunday is weekday number 0. Well, and at this point, let's ignore the other things here for now. At this point, you might notice, if you have ever looked into how on a Unix system the date and time functions work and how the data structures they use are defined, you might find that this looks more or less exactly like the designation scheme for or from the time structures in a Unix system or in POSIX environments. And that is actually what we are doing. Internally, we represent our calendar and our times the same way that we get them with the operating system functions on POSIX systems. We have those other things. This is pretty straightforward. Week of month. We start counting with 0 again, outside, externally documented, and what the configuration file parser expects are numbers from 1 to 6. Internally, we use 0 to 5. Weeks of year is the exact same thing. Here we actually have defined in our configuration, and you've seen that on the slides as well, that we actually define zeros week of the year, which is potentially the first few days of each year before the first, before the Monday that is in the week covering the 4th of January. So this is what we have. This is pretty simple, and what that leads to is twofold. First, those things where we have the potentially lists of things like the days of the month, days of the week, months inside the year, all those things, we represent them internally really just as an array of bit flags. So essentially, we do not have to compare with every potential, for example, month or whatever. We just have, for the case of months, we just have a data structure that consists essentially of 12 flags, each one representing, is this schedule supposed to trigger inside this month? And well, we have those numbers here that we use counting in a less human way, always counting starting at 0, because we compare that in the same way or with the same sort of data structure we get from the operating system functionalities. The reason we do that is pretty straightforward if you think about it, because the scheduler essentially ends up with a list of schedule entries for each job that is scheduled. For each run line, we have a set of conditions to compare. And we have to compare all those conditions for all those jobs that we schedule every minute. In other words, the director, when it is not doing anything particular, like starting a job or checking if a job is still running or answering to your bconsole commands, what the director is doing is most of the time going through the schedule and doing comparisons again and again, a lot of them. So it is very useful, it is very essential that this is as efficient as possible. And to do that in as efficient as possible a manner, first of all, it is very convenient and useful to use the same data structures that we get from the operating system with the date and time information. So we do have less conversion to do. And we end up with those lists of things that we use so that we can really do the actual comparison by doing the plain bitwise Boolean comparisons. So for example, when we want to check, does the weekday trigger, as we have it now, we take, we essentially have a list of bits in the schedule for the weekdays. And here we would have the bit number 6 set. And we can then convert the current time well, in this case, of course, the current day from the current time to its own bit mask in a way by just shifting by the proper number. And those are operations which are very efficient in computer CPUs. And then we have just a very simple logical AND to do and see if our result is still containing any set bit. And that is compared to potentially running into long lists of ifs and doing comparisons one by one. Is this a Monday? And if it's not a Monday, is it a Tuesday? And if it is not a Tuesday, is it a Wednesday? And so on. This bitwise comparison with data structures, which are very easily derived from what the operating system provides to us, gets us to a scheduler implementation which does waste a minimum of time when it's running all the time and around the clock. So this is why we have this particular, admittedly not very readable show schedule output. You will also notice that when we do show schedule, we get, of course, all the other settings that we have in the schedule, all the overrides. For example, here we have for the run line with level full, I override in the schedule to use a particular pool. And we have all the information about the pool involved as well. So this is comparatively readable, I would say. It's a typical keyword equals value assignment list. Okay, it's a long one. We have the retention times even readable, not just presented as plain seconds. All those things are in here. The time and date component of the schedule is not really human readable. If you understand what we have in here, that it's just the list of the numbers we need to compare against. If we have a match, it gets understandable. It is still not really intuitively readable, but it is a representation that is very close to what we use internally, which is actually what the show command is doing. It's always giving the internal well, in a slightly readable manner, the internal data structures for the component we want to show. Well, and for the schedules, it's unfortunately looking not perfectly readable. But I hope this makes it clear what you're seeing. You're seeing all the conditions here. And we essentially need to compare if all those condition matches. And if we have a match on all conditions, for this one, what we had, as we have it configured here, compared to the current date and time, then we run this job level full using those job overrides. That's what's going on. It is, well, I would say it is comparatively straightforward, but only after you really think about it. If actually you are interested in not too much about the bacular internals, which, well, obviously we cannot actually expect everybody to do. But personally, I find that always a bit interesting, but of course, admit I might be slightly biased. If you just want to know what your schedule will lead to, we have, since quite a time, we have another command, the bconsole command, which can give you that information. And I do not know if Alexander already gave you a bit of an overview of what the different bconsole command groups are, but it's kind of straightforward. The show commands give us information about what is in the configuration, what do we have configured. The list command is list jobs, list clients, list job log, all those list commands, they give us information from the catalog database, which is essentially, well, results of previous operations. Whereas we have another group of commands that those are the status commands. Status commands give, well, operational status of the different components. And the components can not only be the client. For example, you have seen the output from status client. You also have seen the output from status director. We can also look into the status of the scheduler by using status schedule equals, I'm going to use that same one so we see how that fits together. And that gives us, well, everything that will happen that is controlled by this particular schedule for the next few rounds. I think it's a maximum of 100 entries. We can override that, and I think like 2 weeks in the future or something. But if I'm interested in seeing what my recently created schedule will actually do without having to dig through all those comparisons and to pretend I provide date and time information and to see what happens when, I can use the status schedule command and see if the results are actually matching my expectations. So in this case, I think they do. I hope they do. I'm only going